Okay, good morning all. My name is Wayne Fagan. I'm chair of D. Howard International Education Foundation, and please welcome to our this live video cast in our series of scientists that speak live to rural schools throughout America. And we have some great stakeholders with us today. First, let me introduce our co-chairs, so to speak, of these videos. UTSA, University of Texas, San Antonio, Cleese College of Engineering and Integrated Design, Jill Ford. And Jill, if you would like to say words of welcome and introduce the others from your team that are on this call.
Thank you so much, Wayne. Hello, everyone. My name is Jill Ford. I'm the Assistant Dean for Student Success at the Cleese College of Engineering and Integrated Design here at the University of Texas in San Antonio. And we are so happy to be a partner with the D. Howard International Education Foundation on our Rural STEM initiative. And so happy to be here today with all of the kiddos at Stapleton Elementary. Hello to you. We're really appreciative, as Wayne said, of Principal Perry and the Aerospace Corporation and all the wonderful teachers and students there at Stapleton Elementary. I have with me my colleague, Carlos Velez, who is our technical director, a master of all things Zoom and video editing. And so I'm really appreciative to have him here too. Thank you so much.
Thanks, Jill. Thanks for all your support. And Leanne from the Aerospace Corporation, I'd welcome and thank you for all of your support. If you'd like to introduce yourself and the other team members from Aerospace Corporation and also our speaker, and then I'll turn the floor over to Jim Perry, the principal of Stapleton, for him to introduce his team. So, Leanne?
Sure. Thank you so much, Wayne. I'm Leanne McGinley, and I have our corporate social responsibility team with me, Lauren Gandera and Rebecca Kem, and we're part of our corporate social responsibility, which is really interested in inspiring the next generation of STEM space scientists and engineers out there. And we have one of our own with us, Nahum Melamed, who is you're gonna hear from later. I'm not gonna spoil anything he has to say, but I'll just close that and just say we're so thrilled to be here with Stapleton Elementary, and happy to see the kids in the classrooms. So good morning. All right, we'll turn it over to you.
Thanks for all your support. And now the real stars of the show, Stapleton School and its students and faculty. And I'll introduce Principal Jim Perry, and thank you, Principal Perry, for all of your support and engagement with the Rural STEM Initiative. And I'll turn it over to you to introduce your team members that are with us today.
Well, thank you so much. I was so anxious to get started. I'll get started now. But we are just so grateful to the D. Howard Foundation, the Rural STEM Initiative, and certainly to the Aerospace Corporation for making this extraordinary opportunity available. I was just chatting with our new assistant principal who's in the classroom right now this morning about the initiative and what a great thing it is for schools like ours that are in rural areas with limited resources available to them. We don't, for example, have a science lab. We don't have a STEM teacher. So our teachers are making the best they can with the resources that we have. And the STEM initiative is such an extraordinary avenue through which we can access just amazing opportunities. And this is certainly a stellar example of that. So for our students to be able to directly interact with such a high-profile corporation, high-profile scientists is a real treat. And we're just very grateful to that and grateful for everyone for participating. I'm here in my office just around the corner from the classroom, and that's our 6th grade classroom. We're a small school, so we have one 6th grade classroom this year. That's Miss Landrino's classroom. A lot of terrific students in there. Ms. Matus, our librarian, was in the classroom as well, along with Dr. Hughes, our assistant principal, and a great group of students who are anxious to learn. So I know they don't want to hear me talk. They get to do that all the time. So I'm going to be quiet. Thanks again for being here.
Thank you, Principal Perry. Let me introduce now, and I'll turn the program over to him, Carlos Velez of UTSA. And also a brief word about our very special guest speaker, Dr. Nahum Melamed, who is the project leader, Embedded Control Systems Department, big title, at the Aerospace Corporation. So Carlos, with that, let me turn it over to you.
Cool. Thank you, Wayne. Yeah, so for here, we're going to go ahead and get started. I'm going to say some just brief formalities as we get our speaker to go ahead and start the presentation. So what we are going to do for the students in the classroom, one thing that's really nice about these presentations is we're also going to give you the chance to ask some questions and all of that great stuff as well. So as the presentation is going on, think of some things that you would like to ask. If there's anything that stands out in your mind, at the end of the presentation, we'll have the students come up and get to ask some questions to our presenters. So keep your minds open and try to think of some interesting things so we can have some good discussion at the end. So with that, we'll go ahead and pass it over and we can get started with our presentation today.
Okay, good morning. Can you hear me?
We can.
Good. All right. So I'm very, very happy to talk to the class at San Antonio. And I love to see the students because sometimes I might have some questions and I love to see, by show of hands who have heard about something. So get ready to participate. If you have questions in the middle of my talk, I'm happy to answer. So it's an interactive talk. So my name is Nahum Melamed. I've been with the Aerospace Corporation for 21 years now. And it really started with my own son who asked, can you come talk to my school about what you do? And since he was in 4th grade. And since then, I've been giving talk to STEM schools, to schools about STEM topics, mainly related to asteroids. So I'm happy to do that again. So by show of hand, I think I see about 20 students-ish in the class today. By show of hands, who loves space? Who likes space? Okay, fantastic. I see about half of the students love space, which is a lot. So we're going to talk about space. What you see on the screen here is our planet Earth with two kinds of objects that are orbiting our class. So the first one here is a satellite. Satellite is obviously a man-made object. We launch satellites to be able to communicate with one another, to use GPS, and to explore into deep space. But our main point today is to talk about the other kind of objects that could come close to our planet, which are asteroids. And asteroids are space rocks that orbit the sun, just like we do. And occasionally the orbits of those space rocks intersect with the orbit of our planet, and they can cause a collision. A collision could be damaging, so we are trying to protect our planet from those objects. So that's the main topic of our talk today. If anybody has questions, and by the way, I'm not seeing the chat, so if there is any questions in the chat or anything like this, just break into my talk and ask me. So we're going to talk about that, but first, let's see where those asteroids come from. What's the origin of those asteroids? And to do that, we are going to use one of the really miraculous technology instruments that we ever built, which is the Hubble Space Telescope. It's a satellite, man-made satellite with a big telescope on board, which when it pokes into deep space, it sees those huge clouds of dust that just circle around and create new stars. Anybody can guess in the classroom what force causes these dust clouds to coalesce together into stars and planets? Anybody can guess? So I'm not hearing the class, but if you are thinking about gravity, you were correct, because the force of gravity pulls those dust particles together, and when they accumulate into large bodies, they can become stars and planets. Let's see how this happens. So this is a small video that shows how our own solar system was created. It started from a large disk of gas that just circulated around the center. And over time, due to the force of gravity, particles accumulated into larger and larger bodies that eventually created such high pressure on the particles inside, they ignited into becoming a star. So all of the stars in the universe that you see were created this way, and our sun is just a special case which delights us every single day. So let's see what are the leftovers of the creation of the solar systems. So the solar system obviously was created from the majority of the disk of dust, but sometimes small particles are left over. They collide with a planet. They bring actually water and materials that are necessary for life. So actually those early collisions potentially have created early life on Earth. But today we are fairly involved. We would like to protect the life that was created by deflecting those big objects away from us and keep our community safe. So here's a quiz that I give at local schools. And I cannot hear anything on your side, obviously, at this point, but I asked them to name those different bodies that you see, starting from the sun and ending in the small one here. I'm not sure if you want to turn on the sound and the class can speak. Is this something that can work, teacher?
I have it unmuted. For some reason, our audio is not working.
Ah, okay. I can hear you. Okay.
Well, if you can hear me, you should be able to hear them.
All right, so let's do a quiz and everybody can shout together. What is this?
What is that? My picture went away.
Oh, the picture went away?
Yeah, on my screen.
Why did it do that?
I don't know.
Should I
No, we're good.
share? I think I am sharing.
Sharing your screen. You're sharing your screen.
Yeah, it's just
I'm
on my
sharing.
end.
Okay.
Okay, I can see it now. All right, here we go.
All right, so I'm going to point to these objects and everybody can shout together the name of the object.
What is he pointing to?
You want me to hold that while you do that for them? While you connect?
Okay, keep on going.
Moon.
Yeah. Okay, so Mercury, Venus, Earth, Mars, Saturn,
Jupiter.
Jupiter. Okay, go ahead.
Saturn. Uranus. Uranus.
Now, is Pluto a planet? No. Pluto is a dwarf planet because there are so many small objects of the same size. If we had to call them planets, we would be inundated with so many planets. So we decided to make it a cute little dwarf planet. Very good. You passed the test. But let me introduce you a new region, which is between the planets of Mars and Jupiter. And that is called the asteroid belt. So by show of hand, who have heard about the asteroid belt? And teacher, I want to see the class, please. So by show of hand, anybody have heard about the asteroid belt? So the asteroid belt is a region of millions of space rocks that orbit the sun just like we do. And occasionally, some of those asteroids leave the asteroid belt to meander around the solar system, and that's where they can find us and collide with us. So our job is to try to find them before they find us and deflect them away. Let's look at a very interesting large asteroid, which is in the solar system. That asteroid, which is called Dactyl, it's called Ida, and its moon is called Dactyl. It has its own little personal moon here, which should start to move around. And this is an animation of a small asteroid about 1 kilometer, almost 1 mile in size, which is a sizable piece of rock. orbiting a huge one, which is 50 kilometers long, about 35 miles long. And so there's about 20% of those asteroids have little moons orbiting them around them. And this is a very, very interesting situation because one of the space missions that NASA had put together in the last several years, which is called DART, deflected a moon of an asteroid, not this one, but something similar to that. And it changed the orbit of the small asteroid relative to its parent big asteroid. It's very, very interesting. This is how we can test if we can deflect asteroids away from the Earth. Anybody of you has visited Grand Canyon or plan to visit Grand Canyon in Arizona, in the state of Arizona? Anybody have been there in the show of hand or might go there one day? So it's an amazing trip. Hopefully one day you will get to travel to Grand Canyon, and not very far from the Grand Canyon in North Arizona, there is a very interesting place which has an impact crater that was created by a relatively small asteroid about 50,000 years ago. The size of the asteroid was about the size of 3 yellow school buses, but the size of the crater was almost a mile wide, about 85 school buses wide. Can anybody tell me why, or think in your mind, why is the size of the crater much, much bigger than the size of the asteroid? And if anybody wants to say, if I can hear it, that's fine. Okay, yeah, great. Yeah, let's hear.
Because of impact.
What caused the big impact? What was the thing that this impact had that created such a huge crater?
Impact.
So I'm going to help you out, and it's called energy, kinetic energy. So the asteroid approached the desert in Arizona at such speed with so much energy that the energy created a crater that is much, much, much larger than the asteroid itself. And so what you see here on the side here is the visitor center. This is a wonderful visitor center to stop by if you are planning to visit in North Arizona. They have large space rocks that came from space, and they give the full history of the solar system. So we actually held one of our conferences there, and were given a tour down to the bottom of the crater. It was a wonderful experience. This is an example of a meteorite that comes from space and hit the ground and survived into the ground. It's made out of iron in this case, and the age of this piece of rock could be about 4.5 billion years old. I have a few of these myself, and it's an amazing thing to hold in your hand a piece of rock or metal from the creation of the solar system. In my mind, it's really, really amazing. So I pass it around when I go to give local talks at our schools. And also I'll encourage them to visit at the UCLA University, which has a meteorite gallery. If you ever come to the Los Angeles area, I recommend to spend about an hour or two to come visit at the meteorite gallery at UCLA. You can talk to the scientist. If you arrange in advance, you can talk to the scientist, and they will walk you through everything that created those meteorites and what they are made out of. If you're interested to know what those meteorites are made of, what are all of these colorful minerals and chemicals inside those meteorites, that's where the scientist can talk to you. Many people are choosing to become a scientist that learns what materials are made out of. So here's an example of a real asteroid that came and entered into the atmosphere over the Russian city of Chelyabinsk 11 years ago in 2013. Somebody was driving to Earth in orbit, he had his dash cam on in his car, and at some point there was a new object in the sky that was brighter than the sun. This is a real asteroid entering into our atmosphere and exploding. So this proves that asteroids are a real thing because millions of people saw it on that day over Russia. And every day we see fireballs of smaller objects that explode into the atmosphere somewhere around the globe. But how do we find those asteroids? We want to learn how those asteroids can be found. To do that, you need to sharpen your eyes, and I'm going to request the teacher in the room to turn off the lights for just a couple of minutes so that we can see if you can attempt to discover a new asteroid that just came into the picture in a bright sky night. So let me show you how it's done. The way it's done is that we point a telescope into the sky, and we are trying to find a new object that moves along the background of the fixed stars. So all of these are stars and galaxies that we see every day. And we are trying to find an object that moves across those galaxies and stars that are already out there. If we find a new object, we put it into the catalog, and then we think what to do about it. So are you ready? Okay, so we're going to take the picture of the night sky before the asteroid was found. So just pay attention. This is the picture of the night sky before the asteroid was found. And the next picture will show a new object in the new photo. And you will want to try to find which one is the new object. So now I'm going to move to the next photo, and there is a new object that was discovered. Anybody can spot it by any chance in your class? I'm going to go back. So this is the picture before the object was found, and now the object is there. And before and after, I see a hand up. Okay, anybody might want to go to the picture and point. I'm not going to be able to see it, but maybe the teacher tell me. Okay, so a student is walking to the picture. He's going to point at some spot there that he thinks is the new asteroid, and the teacher tell me what it is. Okay, I don't know what you pointed at, but I'm going to help you out and show you which one is this new object. Thank you, student. And you can tell me if that was the right choice, because I'm going to put an arrow into it. And this is the new object. Right there is the new object. Is this the object that you pointed?
No, sir. No.
Okay, it's very, very tough job to find to spot those asteroids. So most of the students that I ever gave this talk could not find it. And I'll tell you, I couldn't find it myself the first time I saw this picture. So I had to have this help. Let me just go back. And you see, the night before, this area of space was empty. You see that? And one night later, a new object appeared here, which was spotted by a telescope. So as soon as a new object is discovered, we want to immediately track it down and know its whereabouts, right? So we put an arrow into it, and after a couple of days, we see that the object moved to this region of the sky. See, everything else here stays the same. So this is a new object that moves across the sky. And a couple of days later, it moves into here. So now we have a few dots we connect, and we have the trajectory. Some people are choosing to become orbit specialists, right? There is people who learn how to calculate those orbits of asteroids, of spaceship, of rockets. These are called rocket scientists. They need to calculate where are rockets going to and how planets and asteroids are moving across the sky. Because the first question that pops into my mind here is that where is this asteroid headed in the future? Is this asteroid headed into a collision with our planet Earth and can cause damage like we saw earlier? So we want to prevent that. We want to prevent an asteroid that might be discovered on a collision course with the Earth. We want to prevent it from colliding with our planet. So now you can turn on the lights in the back in the room. We are back to normal presentation mode. Thank you. The way we do that is that we want to build a rocket and a spacecraft that will be launched from the Earth and will be sent out to collide with the asteroid so that the asteroid can be moved away from the Earth. This is something that rocket scientists do every day by launching satellites to space that can do useful functions for us. For example, they can create telephone communications or GPS. They can send weather spacecrafts, climate spacecraft to space, and they send us prediction whether we need to take an umbrella or a jacket that day. All of this is done by satellites that are regularly launched to space almost every day, somewhere around the planet. But in this case, we would like to build a special rocket with a special spacecraft that is going to travel through space very, very fast and collide with this approaching asteroid and deflect it from the Earth. If we didn't do that, the asteroid would collide with the Earth and cause major damage, like we've seen. But what we really want to do is to get the spacecraft to collide with the asteroid and deflect it away from our planet and save the day over some community somewhere around our planet. And so that's what scientists and mathematicians and rocket specialists are doing to build those rockets and try to save our world from that. So in conclusion of my talk, I'm going to say, be prepared, right? Everybody needs to be prepared. And how you do that? Do well in school. Do your best in school, and so you can become a scientist or an engineer or even a musician or journalist or whatever occupation you might choose to be. But do well in school, and you can become one of those people who might save the world one day. Thank you very much. And now I am open for questions by everybody.
Yeah, absolutely. So thank you very much for the great talk. And so now, students, it's your turn. So hopefully you have some, as we've had this discussion on asteroids and how they impact our world. Is there any thoughts or questions that you all have that maybe any more information about any of the stuff that you'd like to know? So if you do have questions, you can raise your hand to your teacher and we can have you come up to the front so we can hear your question and get to see you more personally.
I think we have plenty.
Great, perfect. So we like.
What would happen if an asteroid did hit Earth?
I didn't quite hear it. Can you
Yeah.
repeat it for me?
Yeah, I got you. So what would happen if an asteroid were to hit Earth?
Okay, so this is an excellent question. If the asteroid is not very large, then it's going to simply explode in the atmosphere. You're going to see momentarily a bright explosion in the atmosphere, like the video that we saw a few minutes ago. You might hear a big noise coming from it, but not much will happen. If the asteroid is slightly bigger, it can collide with the ground and create a crater, like we saw earlier at the meteor crater in Arizona. That is concerning because it can destroy a part of the city or a part of a community. It can certainly cause damage, and that's why we want to recruit as many planetary defenders as we can to build those rockets and deflect those asteroids away from Earth before they collide with us. So we need to discover them. We need to build the rockets that will launch the spacecraft to deflect them away, and then make sure that they are deflected away. Anybody from your class who might be interested to become a rocket scientist one day, do well in class and sign on to one of those professions that are required to build those rockets, which is math, physics, chemistry, and excel in those professions. So one day you can work maybe at NASA, and become a planetary defender in your future. If the asteroid is very, very large, it can cause damage. But we want to remember that 70% of the surface of our planet is actually made out of water. So if the asteroid collides into the ocean, it might create some tsunami, but it's probably less damage than colliding with a city or a country. And so it's very, very far in between. Those events really don't happen very frequently, but we do want to be prepared, and we want to prepare in case we discover an object that comes our way. We want to be prepared to launch into it and deflect it away. Thank you very much for the question. So I see there are many others. Okay. Yeah, go ahead. Is there any question, or shall I just read from the chat?
She has a question.
How many
Okay.
asteroids have hit Earth?
Oh, how many asteroids have hit Earth today? Okay. I don't know the exact answer to that. Again, it depends on the size of those asteroids. Really big ones might hit our planet once every several millions of years. So we don't need to worry about those. Really small ones hit our planet practically every day. We are concerned of the asteroids that are somewhere in the middle, right? That collide our planet maybe once every hundreds or thousands of years, and those will not happen very soon. But we want to be aware, we want to discover those. I'm imagining that probably millions of asteroids have hit our planet during the age of the solar system. So if you ever take a telescope and look into the moon, and you see so many craters, impact craters in the moon, you see that we are in the same neighborhood of space. And Earth suffered the same type of collisions with asteroids that the moon have suffered. The only difference is that on the Earth, we have something that's called geological process. We have winds and rain and tectonic plate motion and earthquakes that tend to erase those impact craters. And so we have forests and rivers and mountains. But on the moon, we don't have any of that. The moon is like a museum of the solar system where all of those collisions are recorded into its history. So take a telescope into the moon and you will understand what happened to the Earth during its history. Thank you. Good question.
Lauren has some good information in the chat. I don't know if you want to shout that out, Lauren, or anything about or add. Yeah.
So kind of what Nahum was saying. So geologists have identified nearly 190 impact craters on Earth, but many more have likely been erased by erosion and other geological processes, as Nahum just mentioned. And then astrogeologists estimate that 60 objects with a diameter of 5 kilometers or more have hit Earth in the last 600 million years. And 18 asteroids are known to have hit Earth in the 20th and 21st centuries, but many more have gone undetected due to their small size.
Fantastic. Thank you, Lauren. You're now inducted into the community of planetary defenders.
Oh, thank you, Nahum. We also have a question if AI might help find asteroids.
Yes. Who asked this question? I want to see the student that asked this question. Oh, over there.
It's a student, Wayne, Mr. Wayne.
Oh, Wayne, it is Wayne. Oh,
A little older than
Wayne.
6th grade.
Oh, Wayne.
Student of life.
Oh. Excellent. The answer is yes. The answer is absolutely yes. So I showed you how we try to detect those asteroids as they move across the sky, the night sky. This is something which is very hard to do. You witnessed yourself how difficult it is to find those asteroids with just a glaze into the sky. So we devise computer programs that look at those pictures that are taken one after each other, and they compare one picture to the next and try to find automatically if objects have moved from one spot of the sky to another spot of the sky. So this is something that is running continuously all the time at several centers around the planet. But even this is very difficult to find some of those sneaky asteroids. And so by using artificial intelligence, which are special programs, special technique to spot things that the human eye or even regular automated programs cannot find, Aerospace was able to increase the finding by 10% by using AI tools. So the answer is yes, Wayne, and everybody else. I know that artificial intelligence is now big in the news and everybody talks about artificial intelligence. Here at Aerospace, we're trying to show how to use that for the benefit of humanity. Good question. So let's see, any other questions for anyone?
Yeah, we have definitely some students coming in.
Okay.
What are the chances that a large meteor were to hit Earth?
Oh, what are the chances? What are the chances that a large meteor? Okay, let me make a couple of comments about this question. The first one is about the name of meteor. Meteor, even though sometimes in in the media and in the news, they talk about, oh, a meteor collided with Earth. But meteor is not an object. Meteor is just the light phenomena that occurs when the asteroid passes through the atmosphere and explodes, like you've seen in the video earlier. That light phenomena is called a meteor, but it's not the object itself. So I have actually a question for anybody here on the audience is, where did the name meteor come from? Who invented the word meteor? Anybody can guess, especially in the class?
Anybody know where the word meteor came from?
I see a hand up. Okay.
Where do you think it came from? Meteor. Like. I don't think we know.
Okay. So I will tell you. So the word meteor was invented by the ancient Greeks. The ancient Greeks did not know anything about asteroids, but occasionally they saw those explosions occurring in the sky, and they said, that must be some kind of meteorological phenomena. So let's call it a meteor. But today we know it's nothing but the name meteor stuck. And in some cases, they use it for the object. So going back to your question, let's convert it to what size asteroid could hit our planet, right? How frequently those objects can hit our planet, can collide with our planet. And that depends on the size of the object. Again, if the object is really, really tiny, it pretty much happens every day. Small particles of dust hit our planet practically every day, but they cause no damage because they just burn out in the atmosphere. Very, very large ones might collide with our planet once every millions of years. So I think we are protected by simply discovering the really, really big objects today, and knowing that in the next 700 years, none of them is going to collide with our planet. So we are safe on the really, really big ones. But in the intermediate size range, they can collide with our planet perhaps once or twice a century and cause some damage that could, destroy a few houses or kill a few people. And these are the objects we would like to deflect from the Earth because they are not very, very large, and we can deflect them with relatively small satellites. So we don't need to do anything big except just having a rocket ready to go out into space and deflect the small objects that could collide with our planet in our lifetime and cause damage to our community. So we are not very, very concerned with the really big ones and the really, really small ones, but with the intermediate size ones. And we think we can do something about those.
So can I just clarify something for my students? So the meteor is what is the light that we see as the asteroid enters our atmosphere?
Exactly.
And then the asteroid, if it hits Earth, it can cause a crater. Is that correct?
So if it hits Earth, the piece of the asteroid that made it down to the ground is called a meteorite.
A meteorite, okay.
A meteorite. And I showed a picture of it earlier, which I can probably do. Let's go back to it, maybe just show it.
Forms a crater, or could.
Let me move this here. And let me go back and show.
If you do pull that up, Dr. Nahum,
So
I had canceled the screen sharing, so you'll need to hit screen share again if you want to show the picture.
oh, I see. Okay. All right. Let me do that. All right. Okay, so I'm going to close this one here and share the screen. No, this one. Okay. All right. Can you see me now?
Yes, we're seeing the rock. How old is the Earth?
Yeah, so this is called a meteorite.
Okay.
It is a piece of an asteroid that made it down to the ground, right? Yes, it can cause an impact crater, but the impact crater itself is basically just a hole in the ground that was made by the asteroid itself.
Right.
And in this case, the asteroid just melted away and none of it stayed. So what you see here, I think, came from Argentina, if I remember correctly. I don't know which one. I need to go see where it came from.
Are you aware that we actually have a crater site in Alabama?
Sorry?
We have a crater site in Alabama in Wetumpka.
Oh.
That looks very similar to the one you're showing in Arizona. I was telling my students about it yesterday.
Oh, similar to that?
Yes.
Oh, wow. Where in Alabama?
In Wetumpka. It's right out close to Montgomery.
Oh, well, I need to make sure I come visit it one day because I love to visit impact
I was
craters.
telling my students, we all need to go visit it. Maybe that's a good.
Yes, definitely go on a field trip to there to see the power of nature. No doubt about it. I will look it up later. Maybe Lauren can do that. But I did want to show here in the video that I showed earlier that trail in the sky here. We can probably play it one more time.
Okay.
This is the meteor. Right there, this is called a meteor. It is caused by the object, but that is what the meteor is. Just the light phenomenon.
So that's the meteor.
That's a meteor, right? This is the light phenomena that occurs when an asteroid enters into the atmosphere. The ancient Greeks did not know that that was an asteroid. They thought that was some sort of lightning or something like this in the sky. They called it just a meteorological phenomena, meteor. But the name stuck, but it's not an object. It's just the light phenomena.
Just the light. Okay, we have another question.
Yes.
If the meteor shower was to happen, when would it happen, and like how many years would it be from when one started to another one start?
Can somebody repeat the question? I didn't quite.
She was asking about a meteor shower. I think she's heard of those before. Like when do those happen and how often do they occur?
Oh, meteor shower. So meteor showers are interesting phenomena. Meteor showers happen when the orbit of the Earth intersects with an orbit of a comet. So comets are objects that come from the further region of the solar system, and they are usually made out of ice and dust. When they come close to the sun, the heat of the sun causes those particles to leave off the surface of the comet, and they are being illuminated by the light of the sun, becomes the famous tails of the comet. So those tails extend through millions of kilometers, and they continue to orbit the sun along the same orbit of the comet. So if it so happens the orbit of the Earth and the orbit of the sun intersect with one another, those little dust particles enter the atmosphere at a high rate and create a meteor, what we call a meteor shower. So those meteor showers happens usually about once a year when the Earth orbits around the sun and gets into the same region of that comet and passes through this cloud of particles once a year. There are several events like this around the year. The most famous one is around August 11, I believe, every year. I think it's the Leonids. And it's simply the Earth moving through a cloud of dust particles that left the comet, and they just collide with the atmosphere and create little meteors, right, in our atmosphere. So they open usually once a year because the Earth orbits the sun once every year. And so every year, the Earth passes through the same cloud of particles, and we see the same meteor shower every year, over and over again.
What was the biggest asteroid that you heard of?
Did I understand what's the biggest asteroid that ever collided with us?
She's wondering what the largest asteroid is that you know of.
Oh, the largest asteroid that I know of. I think the largest asteroid that I know of, I forgot the name, but I have a little cute video that can show that if you have time. Maybe Lauren can bring it up, you know, the video that shows the different sizes of asteroids. I showed it a while back. And yeah, so maybe Lauren can track it down quickly, but the largest one is about 900 kilometers wide, which is huge. Fortunately, none of these are ever going to collide with our planet, so we don't need to worry about those really, really big ones. The largest asteroid that we know of that can orbit near our planet is probably a few kilometers, which is large. And so we don't want to have even those large ones come into a near distance with our planet. But you know, there's not much we can do about them, right? They do what they want.
Is it Ceres? Is that the largest asteroid in our solar system?
Which one? Ceres, probably.
Ceres, yes.
Ceres. Yeah. I forgot the name of the really big ones here.
Lauren's ready to share if you want her to. But
Yeah,
you
yeah.
have to stop.
Go ahead and share the video or the. Yeah, exactly. So this is a small one. It's called TC3, about 4 meters, and here we see 22 meters size objects. All of these asteroids have a name, which typically indicate the year they were discovered. And they are compared with other objects that are familiar to us. I see Eiffel Tower, a typical city, and you can see those things start to be large. Can go up to even a kilometer here. And it's going to become much, much larger. So all of those big ones here do not ever come close to the Earth. So we are safe from the big ones.
It really puts it into perspective when you see it with other objects.
Yes, yes. All of these are real objects. All of these are real objects that we have discovered with our telescopes. So maybe some of you might want to be astronomers in your future and point your telescope to the sky to try to find those interesting objects. We do need astronomers to find not just asteroids, but planets and galaxies and explain how the universe works. So some of you might choose to become scientists in your future. So yeah, this is a very nice series of size comparisons of those asteroids.
While we're looking at this, Nahum, I also was hoping that you could share maybe some of the qualities that make a good scientist. Like, should you be curious? What kind of work do you do? Do you just work all by yourself? How does, how do you work?
Oh, no, absolutely. I could not do this work all by myself. It has to be a teamwork, right? So we usually create small teams of engineers and scientists of different specialties. Each collaborate his specialty into the overall. Okay, so yeah, just the last one here is Ceres. You're right, Leanne, and thank you, Lauren. Everyone chooses to become an expert in a different area of science and technology. And so none of us can become an expert on everything. So we pull together small teams with people who are experts in math or science or chemistry or aerodynamics or space. And this team of experts can build those rockets and spacecraft that are used for everyday benefits and also for the discovery and deflection of asteroids. It is hard work, so it's every day we need to meet and do our math and science to make sure that everything closes together, right? So that those spacecrafts are actually going to work. Everything is built on the science and the math here. So this is our day-to-day work, really. Every day, small little things that build up to big projects.
So speaking of big projects, you kept mentioning creating a rocket that would deflect the asteroid. Is that is that being done now? Is there someone building one, or is that something for the future?
Yeah. So currently we can say that we are building those for the purpose of testing whether we can even deflect asteroids. I mentioned the NASA mission that's called DART, D-A-R-T, which you can look up later in your class and maybe show that project to your students. That was a mission that NASA put together to show we can actually build a rocket and a spacecraft and guide it through space through millions of years of distance to collide with a small asteroid and deflect it, just for the purpose of testing. So we have done it. We have shown we can do that for training purposes. But there is no system currently that is sitting on the ground waiting for an asteroid to approach us, simply because those events are so far in between that most likely those rockets will be just sitting on the ground and then thrown to waste after maybe 10 years. Those rockets do not last forever. One of the ideas that we thought here at Aerospace is that perhaps you can build a rocket and a spacecraft that will be ready to go out and deflect an asteroid. And if at some time it wasn't used, we can convert it to send a GPS satellite, for example, and use it for useful purposes. And then build another rocket that will be sitting on the ground and waiting to deflect the next asteroid if it happened to happen. And so we can have replenishment of those rockets and spacecraft and still use them for everyday use. And I see hands up there, so it means there's more questions in the room.
Yeah, so let's do something really quick. So we don't have a ton more time. We're getting close to the time. So let's kind of, I guess, try to get as many questions in these last few minutes before we do wrap up. And then so let's kind of try to get through something pretty quick.
Sure. Okay. Quick questions.
What would happen? So you said you use the rockets to hit the asteroid out of the way. What happens if you miss it?
What happens if we missed it? This is actually an excellent question because it brings up the topic of reliability, right? Sometimes the launch itself is not successful. Sometimes the rocket malfunctions mid-course and it will not impact with the asteroid. Sometimes it will impact the asteroid and it will not be enough. So what we are trying to do is perhaps launch more than one. So we should perhaps build 2 rockets. Each of these could deflect the asteroid and launch both of them. And maybe not use one if the first one has been successful. If the first one has failed, we have another one on the way that could do the same job and increase the chance of success by a lot. Excellent question to whoever asked you. So this is also, you have some scientists and engineers in your class already. Fantastic.
They're good thinkers. All right, I have another one.
Yes.
Where do asteroids come from?
He told you that. Oh, he's asking,
I didn't hear the
where do
question.
the asteroids come from? She's going back to what you said at the beginning.
Oh, okay.
They're created.
Oh, where do asteroids come from? Okay. So you've seen the cloud of dust that I showed in the beginning, right? Where the solar system was created. It was created from a huge cloud of dust that collapsed into our sun, into our planets, into the moons. And the leftovers, the little rocks that you see scattered around here, just didn't make it into the sun or into the planets or into the moons. They just continue to move around the solar system. These are the asteroids. So the asteroids are small pieces of regular rocks, nothing special about them. They just orbit the sun as small, tiny objects relative to the other big ones. That's the origin of the asteroids. Okay, thank you. Good question. Next.
How do people name asteroids?
Oh, name? How do they name asteroids? Good question as well. So in most cases, asteroids are named by the year in which they were found and a couple of letters of designation, which I don't know exactly how they choose those, but these are some random letters and the year. In some cases, the asteroids are given names of famous scientists that either discovered them or are very, very active in the planetary defense community. For example, if you will choose to become an astronomer and you will discover a new asteroid that has some big meaning, or if you will become a scientist in the planetary defense community, then one day might call an asteroid after your name. That's how asteroids are named. So good question. Okay, another question.
Do asteroids get bigger? Like, and like as I orbit, do asteroids grow?
Yes, they're saying, do asteroids get bigger? Like as over time, do they grow in size? Do they kind of stay the
Good
same?
question. No, no, the asteroids do not get bigger. They have the fixed size that they were given when they were formed. But what can happen is that asteroids could collide with one another and break down into smaller and smaller pieces, which are called meteoroids. Meteoroids are small pieces of asteroids that broke off of the bigger ones. So no, they do not become bigger, but they can become smaller.
How long does it take for an asteroid to hit Earth?
How long does it take for the asteroid to hit Earth? It depends on when it was discovered. In some cases, the asteroids are not discovered until the moment they hit the Earth. As an example, the asteroid that I showed in this video here, this asteroid here that I showed in the video, hit the Earth with no warning. And the reason is because the asteroid approached from the sun. We cannot point a telescope into the sun and expect to see an asteroid coming from the direction of the sun. We are just blinded. And so that asteroid approached from the sun and it exploded with no warning. The bigger the asteroid, the more chance we'll discover it before it approaches Earth. And it could be sometimes years and even decades before the asteroid will make a close approach with the Earth. So that's a very good question. It all depends on the size of the asteroid.
Cool. And we'll do one more question and then we'll wrap up from here.
Okay.
So earlier you said that asteroids like form from clouds. Is the scientific name for the clouds nebula?
They were saying how, like you were saying the asteroids are formed from dust. They were saying, is a scientific term for that a nebula? So they're talking, maybe you've heard of nebula before. Are those similar things, different things?
Yeah, so in general, nebula is just like a not very well defined a cloud of dust that like this one here. So these are nebula. You see, they don't have any particular shape.
You'll need to share your screen again.
Oh, I'm sorry. I have to share my screen. Okay, thank you. All right, sorry about that. All right. So this is the nebula that was detected by the Hubble Space Telescope. As you can see, it doesn't have any particular shape. It's just a humongous cloud of dust particles that move around without any specific shape. But because of the force of gravity, some part of this can take the shape of a disk like that and collapse into a star, which is the sun in our case. But once it takes this very regular shape, like a disk shape, from then on, it's a very known process where the star is formed and the planets and the moons and the asteroids. Before that, it's just a random collection of huge amount of dust particles. And some of those stars that you see here went through the same process, right? When you see the star, like these bright pieces here that are potentially stars, they were made from a cloud of dust that collapsed into a star and ignited and sends light that can be detected by telescopes on the Earth. So this is an example of those nebulas.
Cool. Thank you very much. One quick question for the teacher. Could you tell me how many students are in the class? Just curious.
We have 20 students.
20?
22.
22. Okay, fantastic.
Perfect.
Fantastic.
And I'm going to pass it over to Wayne to go ahead and close this out.
And I'm just going to thank the class.
Oh, yes,
I
perfect.
already have fantastic questions, which I enjoyed to talk to you and give you some answers. And I hope that some of you will choose to excel in the math and the science and the chemistry and the physics and become rocket engineers or scientists or astronomers. We need you in our community to make your community safe. Thank you very much.
Thank you so much for your time. We really appreciate it. We've learned a lot.
Thank you. My pleasure.
Thank you.
Yeah, and Wayne, any closing words? You're muted right now, Wayne, but if you'd like to say anything to close us out.
So I just want to close very quickly by, I mean, I've participated, I've had the good fortune of participating and as Carlos and Jill have, and a number of these presentations that we've made. And what struck me, among many other things about this presentation, was the number of questions that we received from the students. And I was just blown away, not only by the number of questions, but by the nature of the questions. And I was thinking, how can we have, because every question sort of raised another question in my mind. And so maybe there's a way that we can make these longer, depending on, we'll have to talk to Principal Perry about that. But just a great presentation. And thank you to the Aerospace Corporation team, to UTSA Cleese College team, to our special guest presenter, Dr. Melamed, and to Stapleton School and the team there and the students there. And Principal Perry, I'll just leave it with you to close it out if you have anything to add.
Well, I will take that opportunity. I just typed in the chat. I wasn't sure if I get a chance to say, and what I wrote was just an extraordinary presentation. I just really appreciate very much making this possible for our students, and I'm really proud of our students. They're amazing kids.
All right, thank you all, and we will. Carlos will do his thing and edit and record the video has been recorded. And then I'll let y'all know when it is posted on our websites. So thank you all, and see you again soon. Thank you. Thank you
Thank
so
you very
much.
much, and do well in school.